Welcome to the follow-up primer to the XAirEdit primer that was published yesterday. This little instructional is going to talk about compression and expansion in theory, explain the science of it, and it's also going to explain it in practice on the XAirEdit, and it'll probably contain a couple of other points that I sort of missed in my brief overview yesterday. Compression, simply explained, is affecting a sound from a transducer, whether that be a microphone or an instrument or any other transducer and source. It's affecting the output level of that transducer or the amplified level based upon input level. So in other words, as the input level changes, the output level is adjusted. That's compression, very simply put. You can see the graph on your screen now that is showing you quadrant 1 of an XY axis, which is where we typically show a graphic of what a compression curve looks like. There's a few elements of the graph that you need to understand. The y-axis represents output level in decibels. It's an increasing metric. Okay, so as you go up, output level gets higher. The x-axis represents the input level in an increasing metric. So as you move to the right here, the input level increases. And lastly, this line, which shows up on some compressors and doesn't show up on others, is the threshold. And the threshold, by definition, is the point at which the compressor begins to engage. So, having explained those elements of the graph, let's talk about it a little more. So you can see here, as the input level increases, okay, in this first line going to the dotted line, okay, as the input level increases, the output level increases. And it continues, to quote my last video and my use of a non-word, it continues linearly up the graph, perfectly diagonally, to infinity. In the real world, it continues until the preamp on your board explodes, or your amplifier, depending which gives way first. So that represents a 1-to-1 compression ratio. In other words, the amount of compression I'm applying is 1 decibel, or minus 1 decibel. No, actually it's 1 decibel per 1 decibel of input level. So 1 decibel of output level to 1 decibel of input level. A 1-to-1 compression curve, or in other words, no compression at all. Okay? This graph goes immediately to a 2-to-1 compression curve, which means exactly the same thing, that, for every 1 decibel of input level, I am going to compress 2 decibels of output level. That would become a -2. So you can see that it basically cuts the angle precisely in half. Dissects the angle, I think is what they call it in geometry. So that's a 2-to-1 compression ratio. And there's everything in between, by the way. These are not your only options on anything but the cheapest of compressors. It goes on to show us a 4-to-1 compression ratio, which is obviously it's going to take off 4 decibels of gain for every 1 decibel increase in input level. Okay? And finally, the graph shows us an infinity to 1 compression ratio, which is going to more or less completely flatten the signal for every decibel of increase in input level. It's going to reduce it infinitely. In other words, it's just going to cap it. It's a roof. It's not going to allow it to do anything beyond the threshold level. Okay? Now, it's important to understand these curves and what they do to sound in the real world. Typically where you're working in the real world is, somewhere around 1.5 to 4, maybe 5 to 1 ratios. When you get much more beyond that, depending on how much of the compression is in the mix, things will start to sound pretty unnatural. I can actually only think of one time in 30 years of mixing that I've ever used an infinity to 1 compression ratio, and that was on drums, on a kick drum in particular. And it was also used, by the way, in conjunction with an expansion algorithm, which does kind of what compression does, except in reverse, and I'll get into that in a little while. So that's really all there is to understanding compression. Compression adjusts output level as input level increases. So as those little blinky lights on your board go up into the green, approaching the yellow and the red, the output level is pushed down. Okay? It's great to use as an effect. It's great to keep those signals out of the red, to keep them from distorting and sounding bad. However, when overused, it makes a sound pumpy, which is the industry term for it. And it's hard to describe other than that. It sounds like you're squashing the sound. It sounds like you're pulling down the fader every time it gets to a certain point, and then it comes right back to life when it gets back below that threshold again. So use compression discreetly, and it'll be your great friend. Overuse it, and it'll ruin your entire mix. Anyway, that's compression in a nutshell, and we'll get to the practical side of things a little bit later. Okay, welcome to part 2 of this exciting instructional video on expansion and compression. This little section is going to cover expansion, which is very similar to compression in its qualities, except that it does kind of the reverse of what compression does. In other words, it increases the output level per unit of input level decrease, rather than decreasing the output level per input level increase, as compression does. Okay, so we're looking at a graph that is similar to what we saw in the compression chapter, if you will. We're looking at quadrant 1 of an XY graph. The y-axis is output level in increasing metric, and the x-axis is the input level in an increasing metric from left to right. Threshold is indicated here. That's the level at which the expansion kicks in. And on this graph, they also note the amount of gain increase. They don't really show 2 to 1 or 4 to 1 or infinity to 1 ratio on this graph like they did on the other one. But we get the concepts at this point, so it's really not necessary. to explain. So we're reading this one kind of backwards, right? As the source, whatever transducer it may be, microphone or a DI box or whatever, as the signal from it declines in terms of its signal strength or its input level, its output level also declines, right? And in this situation here, what is totally linear to the dotted line here represents no expansion at all, right? As the input decreases, so does the output decrease, and they decrease at basically the same rate all the way to zero, where there's no input and there's no output. Now, what expansion does, is as the input level decreases, when it reaches a certain threshold, the gain or the volume, however you want to look at it, is actually increased at a certain ratio. Okay? This probably represents approximately 2 to 1 or something like that. Expansion ratio. So, you know, it could be more, it could be less, right? It can be quite a subtle effect. Expansion tends to be a little less noticeable than compression, but you know, maybe that's just my ears. I sometimes use them together, but compression and expansion, that is, but that can get a little complicated, but you can sure end up with an awfully even signal if you do. So, you know, if you have compression acting, you know, up here as the signal gets to a certain threshold, lowering it there, right? And you have expansion acting down here as the signal gets down to a certain threshold, picking it up, then what you end up with is essentially, you know, an input or an output level that falls in a pretty tight little area between the compression and the expansion. So that is expansion roughly explained. It's a pretty simple concept when compared to compression, or with the foreknowledge of compression, that is. So we'll stop there, and we'll move on to the practical application of these two using Behringer X-Edit software in just a couple of minutes. One more thing. This is also referred to as a knee. Typically in expansion, we use the classic soft knee curve. Okay? And finally, here we have both graphs side by side for comparison purposes. On the left we have the compression graph, and on the right we have the expansion graph. I encourage you to maybe pause the video here and look at these for a minute or two. The real understanding of this, of the science of this anyway, comes with visualizing it, at least for me anyway. So if you want to, go ahead and pause and look at this for a couple of minutes. Okay, we are back in the Behringer X-Edit software. We're going to talk about compression and expansion, and also we're going to talk about sidechain filtering just a little bit. Okay, to begin with, we've already discussed what compression and expansion is in our previous little chapters on this exciting video, and now we're going to look at it, how it looks in the real world. We're looking at our kick drum channel on the compressor tab. Once again, kick is highlighted. Thus, that is the channel we are editing. We're looking at the compression tab, and over here we've engaged the compressor. That's on, that's off. Notice we see the linear relationship of no compression that we discussed before when we turned it off. And notice we see a compression curve when we turn it on. We have these convenient presets. Since this is a kick drum, I'll go ahead and see what Behringer thinks a kick drum should be compressed at. But also note that there's a snare and a bass and a vocal compressor as well. So as we look at the kick drum, we can see that it's fairly aggressive in that this is the threshold at which the compressor is going to engage. We're engaging as the signal comes up on the input side, on the x-axis, at minus 30, right about there. That's where the threshold line would be if this compressor had one, which it does not. That is where the compression begins to engage and reduces the signal, adjusts the curve to that point. Okay, you can see here that we have an adjustment for knee. Okay, remember we talked about the knee being this little section of the graph here, which is the input space or the input range through which the compressor engages and the rate at which the compression engages. As it's set up right now, that knee more or less looks like a classic soft knee curve, but you can see that as we go to a 1, it reduces it, and as we go to 0, it becomes completely angular. That's going to sound a little bit unnatural. So 2 is a good place to have it, but you'll notice at the other end of the spectrum, an extremely long curve, also, while it does have its place, is fairly odd sounding as well. Okay, so we'll leave the knee there at a soft knee. Now, if I were watching this live, this little chart here is labeled a little bit to the right. GR stands for gain reduction. I would see the compressor as it was working. Okay, typically it's a reverse graph, which makes perfect sense, right? Because you're squishing the signal, reducing it. And typically it's in red, I believe it is, on the Behringer X18 also. And it moves down rather than up, as a normal VU meter does. As we go to look at the certain elements of the compressor, just know that typically that is how compression is displayed. Expansion is typically displayed as a red also, but it goes in the other direction. Okay? And you know what? Before we get into the elements of compression, let's note up here that on each channel, it either functions as a compressor or an expander, not both. Although you could, under effects, add an expander out of this list and use it on the channel. Here, you're either compressing or expanding the channel. Under expansion, the graph starts to look really kind of strange because, like I said, we're looking at gain on both axes. But understand that it's doing exactly the same thing that we talked about. As the gain comes down, or the input gain comes down. See, it's basically showing it as the input gain not being allowed to reduce itself at a linear rate. So the gain is being adjusted. Okay? Whereas if I really turn that threshold down to just about, infinity, it's not quite infinity, but it's close, you start to see the line becoming very linear. Okay? So there's a little bit of compression or expansion. There's a whole way too much expansion. Okay, I think we're set somewhere in the 30s here. So I'm curious. I don't know if there's a preset. I think if I hit this preset, it's just going to go back to compression. Yeah, it does. So there's no preset expander for any of these. Which is a bummer because expansion can be quite useful. You really just kind of have to feel your way around and see how it sounds when you work with it. It can be useful on weak sources, but it can also promote feedback. So be careful, but do experiment with it. All right, let's talk about the elements, the adjustable elements within the compression curve. Obviously, ratio we talked about, right? We're at 3:1 right now. Could go up to 4:1. Notice the curve is becoming more aggressive. 5:1, 6:1. We're at 7, 10, and they call it 100. It should be infinity to 1. Behringer kind of has some issues with terminology sometimes. The mix is how much of your compressed signal you want in the output for channel 1, for the kick channel. So I could say, I want to compress the snot out of this thing. But you know what? I don't want to hear only that compressed signal. It's going to sound kind of weird, kind of pumpy. So I'm going to back that off to the point where I only hear about 50% of it in the kick channel. Okay? You can see how that would be different than just adjusting the curve. It would produce a different result. Okay? But by default, typically, these things are set to 100% mix. And not every compressor allows you to adjust that. That's a pretty cool feature. The gain of the compression curve itself, that's the only way to describe it. As I go up, the compressed signal, which is now, again, 100% of the mix, is going to be gained up higher. And it doesn't do this using the preamplifier as gain typically does. It does this through a mathematical algorithm using the processor within the X18. So, be aware of that. Increasing gain here this is not the highest quality compressor in the first place. And really gaining things up here, you're gaining up the compressed signal, is not going to sound super awesome. Okay? You really just want it to the point where, the signal is relatively close when the compressor's off and when the compressor's on. Obviously, the dynamics of the signal are different, but the relative volume, I guess you would say. Okay. The gain envelope is how the compression happens over time. Okay. You can set it to a linear or logarithmic peak or RMS gain envelope. I'm not going to go into what that means. Play with them. I don't want this lecture to be 2 hours long. Play with them and see what they sound like. Obviously, you know, Moog style elements of any sound attack, hold, and release. How quickly does the compressor engage? How long does the compression hold on for? You know, after the threshold is back down below the threshold, how long does the compression hold on? And the release is how long it takes to just let go or reverberate away. Okay? The side chain filter. This is one of the coolest things, I think, that audio science has ever developed. And I'll start by saying, if you want to hear what a side chain can do in the studio, listen to, Rumors by Fleetwood Mac. And you will hear how incredibly tight the bass sounds with the kick drum, almost unnaturally so. Some of that was achieved because you know, they were just great players, but you know, some of it was achieved through science as well, and I'll explain that here. When the sidechain filter is engaged, what it does is, simply put, the processor uses another source to trigger compression. Okay? So I'm working on a kick drum right now, but let's for the sake of example, make a bass channel. It's an instrument. Let's make it, I don't know, feeling blue today. Okay, so it's blue. We'll engage the compressor on it. We'll set it for bass. Now, again, it's highlighted, so that's the one that I'm editing. Okay. I know you're getting sick of hearing that, but it's going to save you some hassle if you learn it. As you can see, compressor's on. We'll go ahead and turn on the sidechain filter. And we're going to set the key, what it is that triggers the compressor, back to channel 1. Okay? Which is the kick. So now, when the kick happens, the compressor is going to be engaged. And it can also be used, you guessed it, on an expansion algorithm as well. So what if I expanded the bass by, you know, some ridiculous ratio of 7-to-1, set at a very low threshold, you know, I got to admit, I don't know what they mean exactly by type. Oh yeah, I do, but I'm not going to explain that in detail. It's going to get really long. Just know that is more heavily influenced. The compressor is more heavily influenced by the sidechain filter than when you're down here. Okay, so we're set around 2, which means it's going to be pretty heavily influenced. Okay, and this is the frequency that it's sniffing for. Okay, where is a kick drum loud? Well, it's quite a bit lower than where it was set. So I'm going to guess, let's set it somewhere around 100. Okay, so it's sniffing for 101.4 hertz, and it's going to compress, or it's going to kick in the compressor sort of mix is another way to put type. Okay. And it's going to look at channel 1 at 101.4 hertz. And when that impulse happens, when that sound happens, it's going to kick in this compressor every time. Okay? Or actually, this expander every time. So what's going to happen in effect is if the bass is happening or playing when the kick drum isn't, it's going to be much quieter. And when the kick drum impulse occurs, it's going to come much louder. Now, what if I set this hold to a long period of time and this release to a fairly long period of time and increase this attack? Now you've got, every time that kick drum happens, you've got 251 milliseconds of bass expansion occurring as well. And if the bass is, relatively punchy, short rhythmic impulses, what the effect of this is going to be that the bass and kick drum are going to sound very, very tight. And it's just a way to kind of synchronize them a little bit and tighten them up. Typically, this was a nifty studio trick. But now in the age of digital processing, it's become possible for us to actually use it in a live environment, which is just incredible to me, being an old school guy. So anyway, that is compression and expansion in a nutshell in the live world, in the practical world. Note that gate also has a side chain. So if you really wanted like an absolute on or off, we could turn on that filter for channel 1, set our frequency appropriately, down here in the kick drum range, right? And what's going to happen, notice that it's set more or less at infinity. That bass is simply not going to make an impulse until the kick drum does. So bass player can be completely out of time, but he's going to sound really tight with the kick drum. This would be a rare occurrence because the bass isn't always playing just with the kick drum, right? But if you ever really needed to tighten something up, that'll do it in a quick hurry. It's unfortunate that we cannot choose multiple side chains. I wish that we could. Because that would, you know what? We can. Look at this. We can choose buses to trigger it. So we could have, kick and snare on one bus, and we could use that as the trigger. And that would really make because the bass is almost always hitting either on the downbeat on the kick or on the 2 and the 4 with the snare. But I digress. Needless to say, there are a lot of possibilities here. This is where the creativity and the artistry of an audio engineer really starts to come out. Play with it, experiment with it, and see how limitless your options are. I hope that you guys have enjoyed a little lecture here. I'll probably follow it up with something that I've forgotten about in this discussion. And again, you guys are the greatest. I love you all in the Lord, and I hope to get the chance to talk to you with your feedback on this video soon. If anybody needs any personal instruction, let me know. I'll be happy to help you. See y'all later.